How's that sound now? It helps if you switch the microphone to on. I turned it off to conserve the battery when after I tested it, and then I forgot to turn it back on. So let me know if sound is coming through good now. There's about a 20-second delay from when I talk to you guys getting it, so just making sure. Yay! This is the lip reading portion of RockSim Live. So yes, my name is Michelle, and I'm the office manager at Apogee Components, and Tim is out. Yay! All the people say they have sound. Tim is out today. He'll explain in the video. He pre-recorded a video for us. It's about 30 minutes long that answers 4 customer questions. And then I have an additional question I can answer that came in via email after he recorded. And then I can also take your questions. Just go ahead and submit them in the chat as the video is playing, and then I will get to as many as I can in the hour with what's left. And yes, I said all my stuff at the beginning, and now I can't remember if there was anything else. So to start, I will play Tim's video. Let me know if there's any problems with sound or anything there. And that's about a half an hour, and then I will go from there. So let's try this.
Well, hello there. I'm Tim Van Milligan, and it is Friday, and I said that I would be back this Friday, and here I am. And unfortunately, though, my daughter has a diving competition today in high school, so I'm over there instead of being live, but I'm pre-recording this morning so that I can go to that event this afternoon when I usually do this RockSim Live. My name, again, as I said, is Tim Van Milligan. I'm going to go over some of the questions for RockSim that we got in this week. And then any live questions that you have, Michelle will be able to answer. And so you can still use the chat to ask your questions. And I encourage you to do so, because this is an audience participation event. So I want you to participate. We're here for you. This is your event. We're here to answer your questions. So right now, what I want to do is to start answering some of the questions that I got in over the last week. And let me change screens here so you can see my screen. All right. So our first question comes from David, and he says that he is they need to be able to present some summary printouts from RockSim. Now, unfortunately, they run 2 or 3 pages long. So what is he saying? And is there a workaround for this? So on RockSim, there's these flight simulations with different motors. You know, you can run all these simulations, and say you want to print these out. But you'll notice that, you know, there's a lot of information here. And when you go to print it out, let me kind of simulate this by printing to a PDF. So let's say I want to print out just the summary here. So I'm going to go to the print icon right here. And what I'm going to choose is I don't want to print out rocket information. I want to print out simulation information. I don't want to print out the graphs. I don't want the details. I just want the table. Simulations table, simulations summary. Let's go with just the simulations table and see what happens. There's another tab right here next to the print selection called additional settings. On this tab, there's a little icon here that says print to PDF format. You need to make sure, if you're trying to print to your actual printer, to uncheck that. If you have it checked, it's going to print to a PDF. I do want to print to a PDF because I don't have a printer right here to show you what it looks like. So I'm just going to simulate that by printing to a PDF, and then I can open it up here on my computer. So I'm going to do that, and it says there's nothing to print. So let's go back here, and this time let's do the simulation summary and say OK. Let's say print. Okay, so it is printing to, it is doing a PDF, and it's going to put it in the RockSim Pro. I'm using RockSim Pro, but this is identical to RockSim. And it's putting it in a folder called PDF print. So to find that PDF that I just sent, I need to look in that folder. So it's in my applications folder. So I'm going to say OK. Then I need to open up my applications folder. Let's see, applications. Here's applications, RockSim. And then inside of this RockSim is a PDF print. So here's PDF print right here. Open that up. And here's the one that I just printed. All right, so you see this. You can see that, yeah, it does, it's not pretty. Is there a way to format that so it's easier to see? The answer is not using the print command, but there is another way to export this information. What you do is on the screen right here, just do a right click on the header column or the header row. No, not on the header row. Inside the body. So right click inside the body. So anywhere in the table, do export table. So you right click and it brings up this menu, and from this menu choose export table. And it's going to export it as a CSV. That's kind of like an Excel spreadsheet. And I'm just going to throw it on my desktop. I'm going to hit save. And so it saved it on my desktop. So if I look on my desktop, here's that CSV. And if I open it, it's going to open it up in a spreadsheet program. On my computer, it's going to open it up in a program called Numbers. You might have Microsoft Excel. And so now when you're in this table, look how much nicer this looks. This is all the data, and you can organize the data. You can sort on it, and that's the beauty of using something like Excel. And so from here, now when you print this out, it'll look just like you see it on the screen. And you can change the fonts on this. You can change the size. So that is the workaround to this issue of printing out all this. Oops, not that. What the heck is going on here? It wants to save it again. Huh. Something's going. It's kind of like locked in a loop here. Let's see if I can close that. I can't get rid of that screen here. Don't save. Delete that. Just trying to get rid of this screen here. It's kind of like this screen is behind something else. And it won't let me cancel or save. Let's see if I can quit RockSim Pro. See if that kicks it out. Say no. No, yeah, that was it. It was kind of, I don't know what was going on there, but it didn't like that. But that was the workaround. And so now we'll go on to the next question here while this is coming up. Let me reorient my screen here so you can see it. All right, so that was that one. And now I got to open up that. I had everything nice and organized here. RockSim Live topics. So okay, so that was the first one. Okay, so here's the next one. Okay, 2 questions. I've noticed in the graph plot of the flight profile. If ejection comes after apogee, the velocity, which reaches 0 at apogee, goes up prior to ejection. The velocity, which reaches 0 at apogee, goes up prior to ejection. I expect it to go negative as the rocket starts to descend. Okay. All right, so I think I remember this question. So let me open up a design again. Cancel out of that. I'm going to go File, Recent. Excalibur. Okay, so he's got a simulation. Let's rerun this simulation here. Load engine. So I'm loading a C65. I want to run a quick simulation. I should probably be doing this in RockSim, not RockSim Pro, because it's a little bit different in RockSim Pro. Cancel there, escape there. Okay, so here's RockSim. Now I'm in RockSim, not RockSim Pro, because most of you are using RockSim. What recent files do I have here? Let's go with a Habu. A Habu, do I have? Here's the Habu on my wall back here, which you can't see because I don't. You're not looking at it. There's the Habu. Let me get this rocket down out of the way. That's what it looks like in real life. Let's go with 2D. So let's see if I got any flight simulations. Okay, we'll rerun a new one here. I'll choose an engine. I'll go with Estes C6-5. Click OK. Flight events, deploy maximum ejection delay, starting state 36 inches, launching straight up. And we have, let's make it a custom wind speed here. I like to run at 8 miles an hour. So I'm going to hit flight profile and just to see what it looks like. So there's the rocket sitting on the pad right down there. When we launch, rocket takes off, does a little wiggly thing while it kind of stabilizes and gets up to speed. And then the parachute pops out and then it's going to drift down and it's going to take a long time to get back down to the ground. So I'm going to slide it to the end. So that's kind of what the flight looks like. It's pretty typical. Okay, so he's looking at the graphs. And let's say he's looking at, what was he saying? Velocity. He's looking at the velocity. So we want to plot velocity. Let's see, has he seen anything else? I expect it to go to the RockSim allow you to figure out, okay. Because velocity is an absolute number. Okay, so there's multiple velocities here is what he's getting at. So let me clear out this and clear out that and just plot velocity, plot the graph. Okay, so as ejection. Okay, so he's we're ejecting a little bit early right here. So here's apogee, here's ejection. So let me go, so I don't know if you caught that. So what's going on here on this particular flight is the rocket was still going up when the parachute came out. And then the parachute came out, but it still had upward momentum. And so it's dragging the parachute behind it until it's slowed down and then it spins over and comes down. But that's not what he's talking about. So we need to rerun this simulation using a longer delay. So I'm going to use a custom delay, and I'm going to use a really long delay, like 10 seconds. And let's launch it again. So expect it to kind of follow the same trajectory, but this time we're expecting it to arc over before the parachute comes out. So it's going up, slowing down. See, when we get to, about 12 seconds is when the parachute's going to come out. Right about there. Okay, so now it went over the top and came down. Okay, so now when we go to plot that one, Let's say end of data. Plot the graph. Okay, so what he's saying is the velocity reaches 0 at apogee. I'd expect it to go negative as the rocket starts to descend after apogee. So here's apogee. So the rocket went up, it slowed down, it reaches peak velocity right near burnout, then it starts slowing down, and then it hits apogee, which is 0. It's the vertical velocity is 0, and then it starts coming down. So he's seeing it starting to rise again. So as the rocket comes over the top, it's picking up speed, which is why you get an increase in velocity until ejection happens and the parachute pops out, and then all of a sudden you just get this massive, okay, I'm slowing down really quick down to this speed right here, which is my descent speed under parachute. So at this point the parachute comes out. You see it's not perfect because it has to slow down while the parachute is still, it still has a lot of momentum and velocity, and it's got to bleed that off before it stabilizes at this velocity right here where it's a nice flat line. Okay, so now there's multiple velocities here. What we're seeing here is total velocity. If you go to the preferences, and if I can choose velocity in the y direction, so let me make this one a different color. So the y direction is going to be y. We'll plot that one, and you'll see that this graph looks a little bit different. Okay, so the black one stayed the same. This one, it continues to fall, but now look at, here's our 0 point right here. So at this point right here, right where it crosses the blue line where the thumb is on my cursor, that is where the rocket starts going over the top. And now it's continuing. It looks like the velocity is continuing to fall, but actually we're in the negative territory here. And so now we're picking up speed negative direction. And then ejection happens. And so from this point on, these two graphs flip. So I hope that kind of explains things. So basically, it depends on which velocity you're looking at. If you're looking at only the y direction, you're going to get velocity as a negative as it starts coming over the top and starts coming down. So I hope you figure that out. It's a little bit of math and it's a little bit of graphing, but I think you can figure it out. Okay, so now his second question is, does RockSim allow you to figure out if a more powerful motor is safe in a particular rocket? I know it can show general flight profile, but will the rocket disintegrate above a particular thrust or total impulse? So basically he's saying, okay, we're just going to push this as fast as possible. Can RockSim predict when the fins start shredding off? And the answer to that question is no. Let me switch screens here. What RockSim is not a structural analysis program. It does not know how strong your rocket is because it depends on how you, the user, build it. The strength of your rocket depends on your building skills. RockSim doesn't know your skills. For example, this rocket right here uses surface mount fins. If I build the rocket different and I use through the wall fins, it's going to be different. It's going to be stronger. Additionally, if I put big, heavy fillets on, those fins are going to be even stronger yet. So RockSim doesn't know how you're building it. Strength comes from technique and skill. RockSim can't figure that out. That's why we can't turn RockSim into a structural analysis program because it would. And the other thing is, we're in model rocketry, we're using organic materials. Organic is in things that were once living. Like these fins were once alive because they were made out of wood. And organic structures aren't uniform. They have a grain direction. They're strong in one direction versus a different direction. Paper is a wood product. So again, it's not uniform strength. Uniform strength things are like metals, and that's why if you were designing out of metal parts, then we could do structural analysis a lot easier, because now it's not how the rocket is built, now it's about what the rocket is made out of. And so that gets a lot easier to predict structural analysis. So RockSim won't predict when your rocket's going to be destroyed. We can only estimate those kinds of things. Next question. Does RockSim calculate aspect ratio? Okay, so what is aspect ratio? Aspect ratio is how you didn't see that because you didn't see my screen. Here was the question. It was from Martin. Does RockSim calculate aspect ratio? And if so, where would I find the data? And the answer is the data, it does calculate aspect ratio, but it doesn't show you the data because you don't really need it. Aspect ratio is regards to fin shapes. Fins that are, I need to create a new fin. So I'm just going to throw another fin on the body tube. This time it's going to be a simple trapezoid fin. Click cancel here. I want to go back into 2D. Okay, so this orange fin, let me move it here so you can see it better. Okay, aspect ratio is, I don't know the exact definition off the top of my head, but it's how narrow the fins are with respect to the span. So if I make the fins really short, that's called a low aspect ratio fin. And if I make the semi-span really wide, that is a high aspect ratio fin. It's really long and skinny. The advantage of a high aspect ratio fin is they are more aerodynamically efficient in glide. So their lift to drag ratio goes way down. And this is why gliders, like soaring gliders, they have those big long wings. So you can get a lot of lift with low drag. But here's the thing. They still create drag. They're just going to create more lift than they create drag. But because they're so big, they create more drag. And when you're trying to go fast, those are going to create such high drag that it's going to slow you down. When you're going up, you don't need lift. You need lift when you're going sideways, when you're gliding. So when you're going up, it's not particularly useful to have high lift or high aspect ratio fins, because you're still going to have a lot of drag. And then again, these long, narrow fins, they're going to be structurally weaker because they're so long. And so they're going to start fluttering like this. And as soon as they flutter, the drag goes up insanely big. And then what's usually going to happen is they're going to snap off. RockSim does calculate the aspect ratio, but it doesn't show you because normally it's not used for anything except for calculating that lift to drag ratio, which you know, the purpose of using a software like this is so you don't have to calculate anything, but it does it behind the scenes. Yeah, it doesn't show it anywhere, which is the question. Okay, so let's see my next question. Okay, so this is from Joshua Smith. So forgive me if if I add, how would I add a tailcone motor retainer or a minimum I think I answered that one last week. I'm pretty sure I answered that one last week in last week live. How to add a tailcone retainer. So if you go here to our website, and if you click on the RockSim Live link right there, this is from January 28th. Okay, it's right here. Do tailcones reduce drag? So in that video, so if you click on this video right here for YouTube, and then you go to the 29 minutes section, so about 30 minutes into the video, we start talking about tail cones, how to add a tail cone to the base of your rocket. So that will answer that question because I'm pretty sure I answered that one last week. Before I turn it over to Michelle, I do want to show you something that's really cool and really neat. We are getting really close to releasing the launch visualizer as a product. Right now we're still in beta testing, and so you can still use it, but if you use it right now and you create an account, we're going to purge your account in the next few days. So by next week, you'll be able to keep an account forever. If you create an account, you just may have to make a new account. But you can, one of the cool features of the launch visualizer is we also, at the same time, created a widget. And what a widget is it's portable. So you're taking the launch visualizer and you can take it and put it in different spots. And what we did was we put it in different spots on our website. So let me show you where some of the launch visualizers are on our website and how we're using them. And right now I've only done the Apogee and the Dynastar kits. So I'm going to go over here to view rockets by manufacturer, and I'll click on that. And so we want to go to the Apogee kits right here, and you can pick any one of these kits. And like I'll say, let's go Exterminator. Okay, so on the Exterminator page, one of the things that we want to do is to allow people to see what these rockets will look like when you go and launch them. And you can do it right now from our website on the page where the rocket is. So if you're scrolling down on the page, eventually you'll get to this section right here. See what your Exterminator rocket will look like when flying from your launch field. So here is the Exterminator, and this is the widget. And so if you click on this right here, you'll see it changed the page, and it's now loading the widget on the screen. Okay, so now it loaded the widget. And so if you have seen our previous videos on the launch visualizer, this looks similar, although it's been squeezed this way because now it's kind of like you're looking at it if you were looking at it on a cell phone. So this is what it looks like, the launch visualizer on a cell phone. So we have all the buttons right here, plus the launch button. But as you can see, if I scroll down, we've loaded the exterminator rocket on the launch visualizer right here on the website. And so now I can launch this rocket and see how high it goes. So I don't think I'm logged in, but as soon as I try to do something, it says log in to use. So I'm going to log in. I'm going to go to my account, sign in. Okay, so now I'm logged in as me. This is my account. And I can see up here, it says, you know, I'm logged in as a premium member. And so now I can choose a launch site. And I'm going to choose this launch site. It doesn't matter which one I choose. And if I scroll down, I can see where that launch site is on the map. And this is fully 3D interactive. Let me swing it around so north is straight up. And let me zoom out on the map, and I want, see, this is the current launch pad location. I don't like that location, so I'm going to move the location. I'm going to move it right here, and to move it right there, you just double click. You see it put a dot there, and then down here at the bottom, which you can barely see, it says confirm the launch site. So I'm going to confirm the launch site. Now I'm going to adjust the launch conditions, and I'm going to launch to the kind of the southwest. And I'm going to choose an engine. This is just like in RockSim. Why is it only showing? I need to have a 29 millimeter engine. Well, I don't know why this is not showing 29 millimeter engines. Here's I want an H motor. Okay, we'll go with an Aerotech F20. And then if I scroll down, I can select my delay. It's a little bit different looking on it in this format because it's skinny and tall rather than wide. But it allows you to run the simulations right here on this screen. So if I scroll up, see, that's the other thing, is the launch button gets kind of hidden behind everything. You got to scroll up to the very top to find the launch button. So now that I've loaded the engine, I can click launch, and it's going to run the simulation. It's taking a little longer because I'm on Ethernet. Or I'm not on Ethernet, I'm on Wi-Fi. Okay, come on, simulation. Well, if anything, if it hangs up for any reason, the cool thing is, since you don't have any software here, you can just come up here to the top on your web browser and just say reload the page, and that will purge it right out. And then if you scroll down again on the page, you know, it closed out the launch visualizer. So that if I wanted to relaunch it, I would just go there. Okay, the launch visualizer does use up a lot of computational power, so you oftentimes get this little error message saying the website is using significant energy. It does use a lot of energy because running those simulations takes a lot of horsepower. So just be aware of that. It's nothing to be concerned about. You know, it's just one of those things. We're doing rocket science here. So that is the launch visualizer. Check it out. I'm just don't know why it was usually those simulations run really fast. So if you want to check out the launch visualizer and get a larger screen, just go to RockSim.com, and then it will reload the visualizer in a new screen. So it has to load it here. Come on, reload. It's usually blazing fast. There we go, much faster. Let's see, am I logged in? No. Okay, so now this time the format is horizontal rather than vertical. And now the launch button is down here at the bottom and it doesn't get hidden behind any of the other screens. Okay, so that's the launch visualizer. Check it out. I'm sure you're gonna like it. We're gonna go live with this hopefully next week early, as soon as I can, because I want you to start playing with it, because it allows you to do a lot of cool stuff and you don't have to load any software. It's already in your browser, which is the coolest thing. Yeah. So I'm going to turn this over to Michelle now, and if you had any questions, here is where she's going to start answering those. So I will be back next week, and so we'll see you then.
Okay, so that was Tim's video. I will say, I noticed you have some comments on things. Tim was on the Wi-Fi, which he mentioned. Just so you understand, our building is like a long rectangle, like really long, kind of narrower, and the Wi-Fi internet is, box is like way at the front in a utility closet, and the video studio is way at the back. And the room is insulated so that the sound doesn't, since it's in the warehouse, there's warehouse noises and stuff. So between that, it's hard for the Wi-Fi to even work just normally back here. And normally we plug into the Ethernet when we're doing these videos, like I'm connected to the Ethernet right now, but Tim, I think, forgot this morning. So that's one of the issues. The other issue is the software we use to record and live stream also uses a lot of computer RAM, so that can also cause the computer to run slow, which also causes the Wi-Fi, the browsers to be a little bit slow or clunky. So that is a little bit of why I'm seeing a couple comments on, try different browsers and things, but really it's just the internet on Wi-Fi isn't great back here. We need to get a Wi-Fi extender at some point. Oh shit. Oh, I'm on. Sorry, I just swore on camera. I was thinking I had turned off the microphone again. I have a question that was emailed to us. So, from Ron Kaminsky, and Ron always sends great questions. So his questions were, I want to try a supersonic Aspire with paper reinforced fins for my birthday. Happy birthday, Ron. The RKT file just shows balsa fins. Can we somehow change to papered fins in RockSim, or should I just weigh the completed rocket, or does Tim have a better idea? In terms of the fins, there's not really a way to do papered fins in RockSim. What you can do is either weigh the fins after they're papered, if you papered them before you glued them on, and just account for the extra weight. If you somehow can figure out the density of the fin overall with the paper and the wood, you could also change the density. So I can show you real quick how to, let me go to screen, share my screen here. Too many things open. Okay. Show you how to do that. So on your fin set here, you can see, I moved this to look at things. Move it back. So your fin set here will have a estimated mass based on the material you're using. So you can just do a mass override using the mass override tab and check this, change your mass. You also need to do the CG. Remember, we've talked about this before. You always need to put the CG in, or it'll assume the CG is the very front tip of the part. And if you're not sure, when in doubt, what I'll do is I will grab the CG of the part, and then just use the existing CG for that. If you want to change the densities are stored in the Rocket menu, edit database materials, and this is where all the densities are. So every time you pick a part and you wonder, how does it calculate what the density, or the weight of my part is, this is how. You tell it what material it's made out of, and then it uses this density in the density column and multiplies it by the surface area and the thickness, if it's hollow or solid, to get that. So you can add the new density here just by clicking add new and then putting in the information and checking the box. That was kind of fast. I wouldn't probably do it that way. That seems really complicated to try and figure out, but I would just do a mass override, honestly, Ron, for that. And then the second part of his question is, would Monaco work instead of paper? And I talked to Tim about this because he mentioned the question before he left. And the problem with Monaco is it's stretchy or kind of bendy, so it doesn't really provide any structural support. So it'd be basically like putting a decal on the fin. If you can find Monaco that's stiff, that doesn't bend, then it would probably work. But because of the adhesive and the way it works, it's stretchy. So, when you put it on the fin, the whole point of papering is to kind of stiffen it up. And the reason the papering works, I think, is because you soak it with super glue, so it stiffens it. Monaco would be like a vinyl decal that just would flex. So it'll provide a little bit more, because then you end up with, like Tim mentioned, the grain direction. It gives it a little bit more of that, but it's not going to be a structural piece to put on it. It'll look very pretty, but it won't really help much with the strength in that case. David, Tim answered your question about the structural integrity, whether RockSim can mention that, can contribute or can calculate that, that it doesn't work. And then Johannes mentions that they are possibly banning short-range missiles in Europe. Maybe that was a joking comment about whether rockets are going to be gone. A missile this comes up sometimes, people's questions. A missile is guided. Model rocketry is not guided. You can't tell your rocket where to go. So you should be fine. People always worry about rockets and missiles, but a missile is something you can direct and tell it where to go. And a model rocket, unless you start getting into thrust vectoring, and even then, it's not really a thing yet. Sergio asks, why on every rocket design, all commercial models that I was running on RockSim become unstable when I added a motor to the configuration using motors from the standard database? I'm not sure why they would be. My guess is something's not set right. What I would say, Sergio, is go ahead and send us maybe an example. Send us an email with that so that we can take a look. I would check your settings. We've gone over that in a couple of the videos of troubleshooting RockSim. You might look and see it. I don't know if you're talking about the rocket. Let me show here. If you're talking about it stable, like I'm clicking on the what you guys are looking at, not the screen. So here it'll have the margin here. So I don't know if you mean when you add a motor, it's going unstable at that point, or if it's going unstable during flight. If it's going unstable during flight and it seems like it should be a fine combination, then I would check your flight settings. So when you go to launch the rocket, check your, and I've covered this before even when I've done it, check your, big ones are starting state. Make sure your launch rod is, pointing straight up instead of something weird. If it's going unstable here, for every rocket to do that would be unlikely. Some will because you need additional nose weight because it's not stable. So I'm not sure without really looking at a bunch of designs. So what I would say is get a couple and then, you know, check all your settings and things, and then try that. So yeah, but yeah, I would try that for there. Any rocket. Okay. Unstable during design. I noticed that, so sorry, I'm reading the comments. JHack says, for anyone seeing this later, the question about negative velocity can't be negative. If you hit 0 and turn around, your velocity just goes back up. I noticed that Tim didn't mention that either when I was watching this beforehand. Yeah, velocity is always a positive number. You can't have a negative velocity. You know, you're always, your speed is, you always have a speed. You just are going in the other direction. So it is there's a word for that, but yeah, you can have negative acceleration, but positive velocity. Rick, I purposely skipped your question because I'm going to show you, we're going to try it together. So Rick's question was, can you demonstrate the rotational alignment of decals on fins? And so I haven't really done this before. Tim usually does a lot of that stuff, and then our graphic designer has been doing it. So we're going to kind of go through this together. We've got about 12-ish minutes left. So first I'm going to show you the cheat because I had to use this. We have 2 newsletter articles about adding textures is what they're called, adding decals to your rockets in RockSim. So I went and pulled those up first on our website. And if you go to to get there on our website, you just do, you go to the how-to and guides, Peak of Flight newsletter, and all newsletters. And then usually what I do when I'm looking for something, unless I know exactly which newsletter it goes to, I just do a find on the page, which is a Command F or Control F, I think, on Windows, or with the Windows and F, I'm not sure on Windows. Seems different every time I try it, but do a find on the page and then just type in the word you're looking for. Don't be too specific, because if you type in, you know, decals in RockSim, what if it's called RockSim decals or something? But if you just type in the word decal and do a search through, this is how I found the newsletter articles. And I just click through, there's a bunch of articles on newsletters, on decals, and then see how to apply decals on the 3D rocket in RockSim. So that's issue 211, and then issue 123 also has it. These are getting pretty old. This is RockSim 7, and issue 211 is RockSim 8 technically, but as far as I know, the procedure still works. We were talking about it because our graphic designer was going to have to do this and learn how to do this, and so Tim pointed him to this newsletter article. So we even use these ourselves as internal training. Newsletter 211. So whether or not we are successful today, Rick, definitely take a look at this article, because it also talks about how to make your decals. And I'm going to skip that step completely, 1 for time, 2 because I don't have those skills really easily. And so we'll go ahead. But I would definitely recommend, if you want to learn how to put decals on rockets, newsletter 211 will be great. And I can throw that in the chat, that link too. There's lots more. Yep, like on the Habu. I actually, while the video for this, while Tim's video was playing, I was actually, when you put your question, scrambling and reading through this, and then I messaged our graphic designer and said, please send me a file. So this is the Habu. This rocket hasn't been released yet. We just got the final parts in the warehouse yesterday, and so now it's just a matter of putting all the pieces together and putting it, and then all the work we do to put them on the website. That actually is the hardest part. We spend about 40 hours of manpower time. Sorry, it's Friday. It takes about 40 hours of work just to get the web pages done. For us, that's how detailed they are. So that's why we don't have, we don't just throw rockets up like some of the, a lot of the websites you go to buy rockets. It has a picture of the rocket, a couple specs, maybe the recommended motors with no altitudes and a price. We could do that too, but we like information, so we know you guys like information. So the Habu is coming soon, and you can download the RockSim file from there. But you can see, yeah, this rocket has these super cool decals on them. So this is what the Habu will look like. A Habu is a Japanese word for a special specific snake. So that's why it's got the snake eyes, the snake, sort of the scales on the fins, and then it says Habu on here too. So I pulled up the finished one, and then I took the decals out. Okay. And so this is the Habu with no decals on it. It's just all plain white. So here we go. Rick, we're doing this together. One of the things the article does mention is if your rocket has color to it, so if you already have like a blue nose cone or green body tube or whatever, when you put a decal on top, it will mix the colors, so you'll get mud, basically. So if you are doing a full body wrap, that's a color, it will mix. In this case, so it's easier, like the decals I think are black, instead of like changing the rocket to black and then putting the gold on top. What you'll get is not visible. The rocket wrap pieces are actually black with the decal on top, I'm pretty sure. So what we do here so you'll need your, pull up the folder. So if I have it open anymore, there we go. So you'll need the files with the different, so you can see the black here, if the black paint essentially, and the fins. And so one of the things that can happen with RockSim with the decals is they can show up backwards. There's a couple reasons that happens. So you may need to make your file. So I have 2 versions of every decal, you can see, because sometimes they show up flipped. And then the other thing it will do is it will, like if you put it on one side of the fin, the other side of the fin will be it's like see-through, so you're actually seeing the decals backwards. That's just the way RockSim works, unfortunately. But so you might need to flip, if you run into a problem where your decals are backwards on the rocket, like your word is backwards or whatever, you'll need to flip your design. So that's why I have two versions of that. So I've got my little PNG files here. So what we'll do is we'll open up the part, and then there's this texture tab here, and you click on that, and then you navigate to your thing. I'm not sure why these are grayed out. This just started happening on my Mac, and I'm not sure what's going on. So we want the nose cone. So we'll start with the regular one. And so once it's on, and I know you talked about fins, Ron, we'll get there. Rick, sorry. Ron was the other question that I keep thinking Ron, even though I know Rick. So if I zoom in here, sorry. And then I rotate. I actually have no idea if that's backwards or not. Looks, he's got kind of a shroop going on. So, and then to move it, you can change this. This is like the 0 point sort of. So you can change some of this. These were what they were before. So my decals are actually there. So there's all these different settings. You can scale it up if your decal is really big. Or really, you have a really big rocket, you can, you don't want to make a decal file that's huge, so you'd make it small and then scale it up. Oh, things are falling off me now. If things don't work right, you can rotate around the axes. The article talks about kind of what each of these are, so I'm not going to kind of reinvent the wheel here. If we need to, we can, Tim can go over this some more because he definitely is more experienced than my having never done this before. So there's that. So you just click on each part that you want to add a texture to. So we've got the body tube. If I put that on, so look at this and see, let me rotate this around. So this is backwards, it looks like, so I need to change that to my reverse file because the Habu words are backwards. Let's try that. It's still backwards. So I'm not sure why they're both showing up. Well, it'd be back to front. So technically, if we turn this around, rock it around, and then rotate it. Okay, there we go. See, now it says Habu, and it's the right way. I'm going to save my work as I go, because inevitably, you know, I'd crash while you're in the middle of it. And then the fins. So let me grab my fins here. And these are backwards. It's pretty clear already that they're backwards. There we go. And these obviously, he made these files exactly for this rocket. So the article talks about sizing it. You can export the fin template, the shape of the fin, so you can pull out that frame, put it into your design program, lay your decal on top so that it matches exactly, and then pull it back in. So there's that there. So that was the super easy, nothing went wrong way, Rick, on how to do that. The article has a specific section on fins. If you'll do that. So, and it also may have a like kind of clear edge, depending on, I'm just looking at the article real quick for it. That's part of the flipping is part of it too. So I'll show you here. Let me grab this. So you can see in the article, it shows you Apogee. So it's right on one side, but the back side will be the mirror image because it's literally projecting the decal through the fin in that case for that. So yeah, this is a good article. I would say, you know, go here to kind of do your first one. Obviously, these ones were set up already for this rocket, so I sort of cheated. But that's the quick and easy way to do that, Rick. And it sounds like that was good enough for now. So I would say try it out. If it doesn't work or you're having problems, that would be a good one to email in ahead of time so we can kind of troubleshoot if there's something that's showing up. I clicked the wrong thing for that. So, and we are right at 3 o'clock. So let me check the questions. I don't see anything else that came in. You guys are all chatting with each other, which is great. So the Habu file, RockSim file, I guess I can switch back here now. The Habu RockSim file will probably be available this week. I'm hoping. We, like everybody, are short-staffed right now, so we have so much warehouse work to do to catch up. So hopefully we can get those new kits. There's actually 3 new kits that are coming out, hopefully in the next week or 2. We just got the final piece in for Zephyrs. If you've been waiting for a Zephyr that was out of stock, we just got those in this morning. So we got to start production on those. There's just a lot of stuff that's coming in the door, which is great. We're finally getting some shipments in for stuff we've been waiting on, and now it's just a matter of putting parts in a bag and sealing it up so you guys can have access to those. But yeah, like Tim mentioned, the launch visualizer will hopefully be out in the next week or so too. So we're working on that. There's a lot of big things that are coming from Apogee, hopefully in the next couple weeks. So that'll be exciting. So keep checking in. Tim showed you where most of our stuff is, and most of you guys are. I recognize you show up a lot here, which I appreciate. It's great seeing the same names over and over. I'm not sharing my screen anymore. Just as a reminder, if you need to contact us, we've got our contact on here. Contact form, you can give us a call. And as long as we're not basically in a staff meeting, we'll answer the phone. There's all the resources are here under how-to and guides. We've got our newsletter articles, which we looked at today. We've got advanced construction videos. Some of those deal with RockSim. A lot of them are construction stuff. Under software is all of our RockSim video tutorials. On the launch visualizer, I always want to type in launchvisualizer.com, which does redirect to rocksim.com, so you can do that as well. The help here, I'm not sure if Tim's done a lot of talking about the help because they were working on it. Oh, that's the home. The homepage has why would you buy the launch visualizer? So if you're curious and want to know more about the features, that is back on the, when you first go to the page, it'll be the, jumping right into the rocket. But if you click the little home icon, it will take you to those. And then if you click the little rocket, it'll go back. But the help menu, we just updated it this past week. So we have a ton of how do I use this software, all the different tabs, the different viewers, the 3D screens where you can see the rocket flying when it's on the pad, using your account, how do you manage that, some Q&A questions that have come in, how do I sign up, how do I pay for things, which we're not quite to the paying part yet. We will get there soon. And then tutorials and references, and we'll be updating this as people use it. You guys have been giving great feedback, the people who are beta testing, asking questions here. So as we get more questions in, we'll add to this. But this is also a great resource for the launch visualizer. So and if you can't find an answer to something, you always can drop the questions here in the chat. You can send an email. We're always quick to respond. You should get an answer within 1 business day. If you didn't see that, either it was the weekend, although Tim answers emails on the weekends a lot, or check your junk mail, because it's our policy to respond within 1 business day. So we're always writing back to you if you have any questions, or we'll answer here. So I think that's everything for today. Thank you guys. You're so enthusiastic, and I appreciate your patience with me when Tim's not here. I've been using RockSim for a long time, but I don't do some of the technical stuff that he plays with a lot. So things like adding decals to rockets. It's kind of fun actually because I learn things or refresh my memory on things too. So it's a lot of fun. So with that, we will end the chat. It says, can you use the launch visualizer to launch from the Koi Pond Rock? You can launch, if you have the GPS coordinates, you can launch from anywhere. So yep, you should be able to launch from the lake for the water. The fish might not like it, but that's the great thing about the launch visualizer is it's all virtual, so you're not hurting any fish when you're launching. Okay, so that's it for today. Tim should be back next week, and thanks a lot for everything. We'll see you guys next time.